Hello guys, welcome on Tesla Eduventures. In this video, we are going to discuss the average power loss in an AC circuit. So first of all, let me remind you that if you are currently studying alternating currents, then definitely you have studied the capacitance as well as electromagnetic induction. And if you have studied these two chapters, then you must be having the knowledge that capacitor is a device which is used to store the electrostatic potential energy, and inductor is a device which is used to store the magnetic potential energy. So these both devices are used to store the energy, and resistance is a device which develops heat. It does not stores any energy. In fact, it produces heat, and it produces heat loss in the circuit. So actually, if there is a loss of power occurring in any AC circuit, then that loss of power will be definitely due to the heat developed across the resistance. Now we are going to discuss, we are going to derive a formula of average power loss in any AC circuit in this video. So first of all, let us consider that there is a sinusoidal voltage V is equal to V naught sine omega t, which we have applied on any AC circuit. And as we are generalizing the formula, so we cannot say that which type of AC circuit is that. So we cannot say that what will be the exact value of phase difference between current and voltage in this circuit. It depends on the circuit only. So we are just assuming that the current is having a phase difference of phi as compared to the voltage. So I have assumed this current where phi is the phase difference between current and voltage. So I can say that the power is V into I, and this is instantaneous power, so it would be V naught I naught sine omega t and sine omega t plus phi. This is obviously the instantaneous power. Now we can say that sine A sine B can be 2 sine A sine B can be written as cos A minus B minus cos A plus B. Okay, so we can write down the power as V naught I naught upon 2. Cos A minus B is cos phi. Actually, cos minus phi is also cos phi, and the cos A plus B is minus cos 2 omega t plus phi. Okay. Now we know that cos theta has a average value of 0 when theta is variable. But when theta is constant, obviously the average value of cos theta will be the same, because obviously we know that if somebody is asking that what is the average value of cos 60, then we can say easily that the average value of cos 60 will be half, because its fixed value is also half, and it is not varying with any time or something else. So the average value of any constant function will be the same value of that function which it has actually. So we can say that average value of this function will be 0, because theta is variable, it depends on time. So in full cycle, average value will be 0. So the average power loss in AC circuit will be V naught I naught cos phi by 2. Now we can write down V naught by root 2 as Vrms. So it would be Vrms and IRMS cos phi, where phi or where cos phi is also called as power factor, and phi is called as phase difference between voltage and current. Okay, and current. This is the power factor. Okay, now what we can say that uh, average power formula is this one, and this cos phi, which is also known as power factor, is deciding that what will be the power loss in any circuit. For example, in pure resistive circuits, in pure resistive circuits in which there is pure resistance, the phi will be pi by 2, 90 degree, and cos phi will be 0, cos 90 will be 0, and the average power, in pure resistive circuit, the phi will be equal to 0 degree. I'll explain this phase in the later part of this series, in the upcoming videos, that why I am saying that in pure resistive circuit voltage and current have 0 phase difference. I'll explain it in the later videos. In fact, in just next video I'll explain this thing. And cos 0 is 1. So average power loss in any resistive circuit, pure resistive circuit, is Vrms, Irms, and cos phi. Now we can say that Irms is Vrms upon R, where R is the resistance. So average power loss will be Vrms square upon R. Cos phi is 1. Okay, and obviously now if we talk about pure inductive or pure capacitive, so in these circuits phi is pi by 2, and therefore we can say that average power loss in these circuits will be 0. And this is very evident as we have already discussed that in pure inductive or capacitive circuits, the devices which are used are capacitance and inductance, which are known to store the energy, not to develop the heat. So obviously the average power loss in those circuits in full cycle will be 0. So this is the first thing. And if in any case you are questioned about the heat developed in the circuit, so the heat developed upon time taken will be average power loss. So if we need to find out heat developed, then we can directly find out average power loss, and we can multiply with the time which is given in the question, in which we have to find out the heat developed. So guys, this was it in this video, and in next video I will be starting the alternating AC circuits. Thank you.